Hey guys, we had some questions on problems 1 and 7 in Achieve 4.1, so thought I would look at them here with you. The first problem looks at f of x is equal to the square root of 1 plus x. And the value of x that you're interested in is, remember, a is always the value that you're interested in, is x equals a is equal to 4, and the change in x is equal to 0.2. So we're supposed to approximate the change of f in our function as x moves from 4 to 4.2. Now our approximation formula for that tells us just to evaluate the derivative at 4 and then multiply that by 0.2. So the first thing I need to do is take the derivative. We know that this is the group to the 1/2 power. Thus its derivative is going to be 1/2 times the group to the negative 1/2 power, or that's the same thing as 1 over 2 on the square root of 1 plus x. Now I can go down and answer their first question. What is delta f approximately equal to? Well, delta f always approximately equals the derivative evaluated at the point of interest times the change in x. In this case, that's the derivative evaluated at 4 times 0.2. You'll notice I plugged a 4 into this derivative, gave me 1 over 2 times the square root of 5. I multiply that by the change in x, which is 0.2. That 0.2 would go to the numerator divided by 0.2. That's where the 0.1 divided by the square root of 5 came from. I went to my calculator and I got this answer. Now, on Achieve, it's asking us to give that answer to 7 decimal places, so I rounded to 7 decimal places there. I checked this out on it. I get 0.0447214, and I believe that that's going to be the first answer there. Now they're going down in the other problems here. The second one is wanting us to calculate the error in the linear approximation, and then the percentage error. Well, you can't find the error in the linear approximation if you don't find out what the true value is supposed to be. So you'll see that's what I did here next. The actual value, or the actual change in f in this function, all it's doing is it's going to measure the change in the y values as f goes from 4 to 4.2. So notice I took y2 minus y1, the function evaluated at 4.2, minus the function evaluated at 4. Well, the function evaluated at 4.2 is just the square root of 1 plus 4.2. The function evaluated at 4 is just the square root of 1 plus 4. So then I can say, well, that's the square root of 5.2 minus the square root of 5. And again, I needed 7 decimal place accuracy for that. That's not one of the final answers in the problem, so I didn't box that in. But I get the 0.0442829 there. Now, the next component in our answer is the error in our approximation formula. So here's our approximated change in the y values. Here's the actual change in the y values. The error is just the absolute value of the difference of those two numbers. It doesn't matter the order, because you know since it's inside of an absolute value, it's going to be positive anyway. So I took this number minus this number, stuck it inside of an absolute value. And now be careful with that, because I could see a lot of people not taking the correct answer there. So I'll show this out, the 0.0442829 minus the 0.0447214. So please notice your calculator will give you scientific notation here. That's no big deal. We should easily be able to understand that. That E negative 4 means there would be 4 zeros to the left of the first non-zero number, including the 0 to the left of the decimal. So I would prefer not to put that 0 myself, but I'm thinking, okay, that would be 0.000, and then I have 4385. Now it's wanting 5 decimal place accuracy for this portion of the answer. So you'll see I rounded to 0.3 zeros and a 44. And again, the only reason I did that is because Achieve specified 5 decimal places here. So I take that answer, 0.123, 3 zeros, followed by the 2 4s. Now the last one, it's wanting the percentage error in terms of 2 decimal places. So I can go in there and say, okay, percentage error here. The way I found that through my work is I said, well, the percentage error is nothing more than the error and I'm assuming they will want the rounded version of the error, just like they had you put in for the answer for the error. So the 5 decimal place error answer divided by the 7 decimal place actual value. Please don't use the approximated value, use the actual value when you calculate the error. So it's the error divided by what the actual value is supposed to be multiplied by 100%. When I did this on the calculator, I got the 0.99. So notice I have the error already in here. You can ignore the sign. Divide that by 0.0442829. Multiply that by 100. And again, keep in mind, it's going to tell me it's negative. I know it's an absolute value, so I just ignore the negative. And I'm getting the 0.99 there, which will match my answer here. I can go ahead and enter that in. And please notice, it's already in terms of percentages over here, so I do not put the percent. It's already assumed, 0.99. And now I check that answer, and perfecto, we get it right. And now you say, okay, so that one was pretty cool. The next question that I had some questions about was number 7. Let's look at it with you. Number 7 is just asking us to estimate the change in y using differentials. Pretty cool stuff. So the y value in this problem is the cosine of 7x, and the particular value of x we're interested in here is pi over 42. And we know that the change in our function is it's going to go an increment of 0.015. So we're trying to find out how much does the y value change as x moves from pi over 42 to pi over 42 plus 0.015. We use our derivative in order to do that. I can say dy dx would equal derivative of cosine is negative sine of 7x times the derivative of that angle 7. So I get my negative 7 sine of 7x. Thus, dy is just equal to this function times dx. Now I start plugging in information for it, and I can say delta y is the negative 7 sine of 7 times pi over 42 times the 0.015. From this step to this step, I just said 7 pi over 42. It's the same thing as the sine of pi over 6. And I know that the sine of pi over 6 is simply 1/2. So I have negative 7 times 1/2 times a 0.015. And you can see here that I'd get the negative 0.0525, which rounds to a negative 0.053. That should be our answer here. If I go back here and try it, so I can say it's a negative 0.053. I check that answer. This should be right. And you can see, correct. So hopefully this helps you out with these two problems, number 1 and number 7 from the section 4.1. Again, please let me know as soon as you have any questions. I'd be glad to help you out.